Example 1 here on the product moment correlation coefficient is taking a look at calculating the product moment correlation coefficient. So here what we've been given is this table of data for two variables x and y. Now here in this case what we want to do is find the Pmcc using this data. Now to do this all we're going to do is use our scientific or graphical calculator. And what you need to do here is go on to the statistics mode, and from there there's usually a button called either menu or mode from where this can be accessed. What this will give you is multiple options here, one of which will read like a regression line. For example, this would be a plus bx. Okay, so this is what you're looking for here. So a plus bx. So this is a regression line. Okay, so we're going to click this option here. And what you'll be given is you'll be given a bit of information here, but all we simply need here from this option is the value of r. Remember, r gives us the product moment correlation coefficient for the data. So we require r. And if we read that off here from our calculator, what you should obtain is 0.9704 there. Okay? And that's simply the solution for example 1. Example 2 here on the product moment correlation coefficient is taking a look at a hypothesis test for the Pmcc. So here we've been given two variables x and y, and we're asked are they correlated to 5% significance. So here this is a hypothesis test, so the first thing we need to do is define the hypotheses. So we write those as h0, and remember for h0 here it will always be the same, and it doesn't change whether it's a one-tailed or two-tailed test, and in this case it's always rho equals 0. Okay. Now for h1 here, this can change, and it changes depending on whether we're working with a one-tailed or two-tailed test. Now again, we always use rho here, but we have to decide whether this is a one-tailed or two-tailed test. And the way to decide here is to check the wording of the question. We're asked are the following correlated. So in that case, this doesn't imply whether it's positive correlation or negative correlation, just that there's some form of correlation here. So in that case, to take this into account then, this must be a two-tailed test to check for both positive and negative correlation. So this is a two-tailed test, and for a two-tailed test we write not equal to 0. Okay. So what we need next here is the R value. Okay, we need to find the Pmcc. So here, just like we did with example 1, we're simply going to use our calculator here. Okay, so using calculator, what we get for R is that R is equal here to minus 0.3587 there. Okay. We also need the significance level, which is given in the question here as 5%. So we'd write alpha equals 0.05, but we have to be slightly careful here. Remember, this is a two-tailed test, and for a two-tailed test, we halve the significance level here. So in that case, we use 0.025 here. Okay, that's very important. If you use 0.05 by mistake here, you'll get off an incorrect value from the formula book there. Okay, so make sure that we use 0.025 there. Now all we need is the critical value from the table, and then we can compare here. Okay. Now checking the critical value from the table here, remember we've got 10 data points here from x and y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equal to 10. Okay. So in that case, reading from the table now, using our formula book here, the critical value here is 0.63. So 0.6319 there. Okay. Now here, this also includes the negative value for this. So it's plus or minus 0.6319. Okay. So in that case, what we can do here is we can just draw a number line from -1 to 1 here for Pmcc, and we can check where this value is going to lie here for our R value here within the critical value. So doing that, what we'd get here is this is 1, this is -1 here, and we'd have a 0 in the middle. Now what we've obtained is that the critical value is plus or minus 0.6319. So let's say that's there, that's 0.6319. And let's say here is minus 0.6319. So we would reject H0 if we lie within these areas here. Okay, so if we're in this area here, we would reject, and again we would reject here. Okay, now the value we've obtained for the Pmcc using our calculator here, if we do this in a different pen colour here, was minus 0.3587. So let's say that's there. Okay, minus 0.3587. Okay, so that's our value. Now we're clearly outside of this critical region. Okay, so in that case, if we lie outside the critical region, we just accept H0. Okay, so if we give the conclusion here in orange, that means we accept H0. So we accept H0 and we say there's insufficient evidence. Insufficient evidence. So there's insufficient evidence to suggest the variables are correlated. Okay. And that's simply all we need there for our conclusion regarding the outcome here. So we've accepted H0, we've just said there's insufficient evidence to suggest the variables are correlated. And that gives us the solution to example 2 there.